Welcome to our journey through time, where we explore the fascinating story of how our planet Earth was born. From a swirling cloud of gas and dust to the vibrant planet we call home, we'll trace the incredible journey across billions of years that led to our existence. Fasten your seatbelts as we're about to embark on an epic adventure through the cosmos, witnessing collisions of celestial objects, the birth of stars, and the delicate formation of our planet. Picture this. 4.6 billion years ago, our cosmic neighborhood looked vastly different. The vast emptiness of space was filled with a colossal cloud of gas and dust, known as a nebula. This nebula stretched across light years, a cosmic canvas waiting to be painted with the birth of stars and planets. Instead of planets and asteroids, this immense cloud of gas and dust dominated the scene. It was a stellar nursery, a place where new stars and planetary systems were destined to be born. The nebula was a swirling mass of hydrogen and helium, the lightest and most abundant elements in the universe. This wasn't just any nebula, this was a stellar nursery filled with the raw ingredients for stars and planets. Within this cosmic nursery, regions of higher density began to form, creating pockets where gravity would start to take hold. Hydrogen and helium, the lightest elements, swirled alongside remnants of ancient stars, peppered with heavier elements like carbon, oxygen, and iron. These heavier elements were the byproducts of previous generations of stars, now recycled into the fabric of the nebula. These elements, forged in the hearts of dying stars, would become the building blocks of everything we know. The nebula was a rich tapestry of cosmic material, each element playing a crucial role in the formation of new celestial bodies. Then, from the depths of space, a shockwave, likely from a nearby supernova, rippled through the nebula, disrupting its delicate equilibrium. This shockwave compressed regions of the nebula, causing them to collapse under their own gravity. This disturbance set in motion a chain of events that would lead to the birth of our sun, and, eventually, our planet. As these regions collapsed, they began to spin, forming protostars that would ignite into new suns, surrounded by disks of gas and dust that would coalesce into planets. Imagine the chaos as gravity, the architect of the cosmos, took hold. In the vast expanse of space, gravity began to weave its intricate web, pulling and tugging at the very fabric of the universe. It was a dance of forces, unseen yet immensely powerful, setting the stage for a cosmic drama. The shockwave from the supernova had compressed parts of the nebula, causing it to collapse in on itself. This wasn't a gentle process, it was violent and chaotic, with immense forces at play. The nebula, once a serene cloud of gas and dust, was now a battleground of energy and matter. As more and more material was drawn inwards, the center of this collapsing cloud grew denser and hotter. The gravitational pull intensified, dragging everything towards the core. It was a relentless process, with the cloud's heart becoming a furnace of unimaginable heat and pressure. Temperatures soared to millions of degrees, the intense pressure fusing hydrogen atoms into helium, releasing unimaginable amounts of energy. This nuclear fusion was the spark, the ignition that transformed the cloud into a blazing beacon of light and heat. This wasn't just any release of energy. This was the birth cry of a star, our very own sun, bursting into existence. It was a moment of creation, a stellar genesis that would shape the future of our solar system. The sun's fiery birth wasn't a solo act. Its powerful gravity acted like an invisible hand, shaping and influencing the remaining material in the surrounding disk. This gravitational force began to organize the chaos, pulling dust and gas into a structured formation. This swirling disk, a cosmic playground of dust and gas, held the seeds of planets to come. Within this disk, countless particles collided and coalesced, gradually forming the building blocks of planets, moons, and other celestial bodies. The stage was set for the creation of a solar system, with the sun at its heart, guiding and nurturing the formation of its planetary family. Now imagine yourself shrinking down to an incredibly small size, drifting through this swirling disk of dust and gas. Around you, tiny particles, remnants of the nebula, collide and stick together. These particles, drawn together by electrostatic forces, begin to clump, forming larger and larger objects. Over millions of years, these clumps, called planetesimals, grow from the size of pebbles to kilometers wide, like mountains floating in space. These planetesimals weren't just sitting still, they were on the move, orbiting the newborn sun, bumping into each other like bumper cars in a cosmic carnival. Chapter 4. A planet is born. As these planetesimals grew larger, their gravitational pull intensified, attracting more and more material. It was a cosmic competition, with the largest planetesimals pulling in their smaller neighbors, growing larger with each collision. One of these victorious planetesimals, destined for greatness, would eventually become our Earth. But the early Earth was a chaotic and violent place. It was constantly bombarded by leftover debris from the solar system's formation, a relentless cosmic hailstorm shaping its destiny. Chapter 5. Earth's Fiery Forges. Imagine the early Earth, a molten ball of rock, its surface a fiery inferno. Constant collisions with asteroids and comets, along with the decay of radioactive elements within its core, generated immense heat. This heat melted the planet's interior, causing a process called differentiation. Think of it like separating oil and water. The densest materials like iron and nickel sank towards the center, forming Earth's core, a giant ball of molten metal. Lighter materials like silicate minerals rose to the surface, forming the mantle, a layer of molten rock surrounding the core. Finally, the least dense materials cooled and solidified on the surface, forming the very first crust, the foundation upon which we stand today. Chapter 6. A breath of air. Volcanoes erupted across the young Earth's surface, spewing gases from the planet's interior into the sky. These eruptions released water vapor, carbon dioxide, nitrogen, and other gases, forming the planet's first atmosphere. This early atmosphere was very different from the one we breathe today. It was thick and hot, a toxic cocktail that would be deadly to most life forms we know. As Earth continued to cool, water vapor in the atmosphere condensed, forming vast oceans. These early oceans were likely acidic and hot, but they would eventually become the cradle of life. Chapter 7. A Celestial Dance. In a dramatic turn of events, a Mars-sized object named Theia collided with the young Earth. This wasn't just any collision, it was a cataclysmic event that nearly shattered our planet. Debris from this impact was ejected into space, forming a ring of molten rock and dust around the Earth. Over time, this debris coalesced, drawn together by gravity, forming our moon. The moon's formation wasn't just a cosmic spectacle, it had profound effects on Earth. Its gravitational pull stabilized Earth's rotation, preventing wild swings in our planet's axis and creating a more stable climate. This stability would be crucial for the development of life. Chapter 8. A Time of Bombardment. The early solar system was a chaotic place, with leftover debris from planet formation hurtling through space. Earth, still in its infancy, endured a period known as the Late Heavy Bombardment, a time of frequent asteroid impacts. These impacts, while destructive, may have played a crucial role in delivering water and organic molecules to Earth, the essential ingredients for life. Over millions of years, Earth slowly cooled, its surface solidifying, its atmosphere transforming. The stage was set for the most remarkable chapter in Earth's story, the emergence of life. Chapter 9. And then, there was life. The early Earth, now a calmer, more hospitable place, provided the perfect conditions for life to emerge. The planet, once a chaotic and violent environment, had transformed into a world where the basic ingredients for life could come together. Volcanic activity had subsided and the atmosphere had begun to stabilize, creating a more predictable climate. Liquid water, a stable environment, and the right mix of chemical elements set the stage for the miracle of life. Water, essential for all known forms of life, flowed freely across the planet's surface, creating rivers, lakes, and oceans. The right chemical elements such as carbon, hydrogen, nitrogen, and oxygen were present in abundance, allowing complex molecules to form. Around 3.5 billion years ago, in the depths of Earth's primordial oceans, the first single-celled organisms appeared. These tiny life forms, invisible to the naked eye, were the pioneers of life on our planet. They thrived in the nutrient-rich waters, using simple chemical reactions to harness energy and grow. These simple life forms, harnessing energy from their environment, marked the beginning of a journey that would lead to the incredible diversity of life we see today. Over time, they evolved and adapted to their surroundings, developing new ways to survive and reproduce. This process of evolution driven by natural selection allowed life to become more complex and varied. From these humble beginnings, life evolved and diversified, eventually colonizing the land and transforming the planet's atmosphere. Plants began to grow on the land, producing oxygen through photosynthesis and creating new habitats for other life forms. Animals followed, adapting to life on land and giving rise to the rich ecosystems we see today. Over billions of years, life shaped Earth, creating the conditions we depend on for our existence. The interactions between different species and their environments have created a delicate balance that sustains life on our planet. From the tiniest microorganisms to the largest animals, every living thing plays a role in maintaining the health and stability of our world. Outro, our cosmic cradle. And that's the incredible story of how our Earth was born. From a cloud of gas and dust to a thriving planet teeming with life, our journey through time shows just how remarkable our world truly is. The next time you gaze upon a starlit sky, remember that we are all connected to the cosmos. The atoms in our bodies were forged in the hearts of stars, and the molecules that make up our very being were present at the birth of our planet. Thanks for watching, and don't forget to like, share, and subscribe for more fascinating explorations of our universe.